So today we're going to be talking about section 4.6 in your book. Really, it's a fairly short lesson, and it is just formalizing what a relation is and how it is related to a function. So in this first section, as we've seen before, I have a problem for mixed review. Here they want us to make a table and graph the function. So we don't really have a graph there, so we could sketch the graph out, or we could just complete the table. But we know that we're just taking those values for x and plugging them in to solve for y, and we've been doing that. So I'm going to go ahead and put those answers here when you plug in each value. Okay, so if I plug in -1 here, that gives us -4 minus 1 would give us -5. And then, of course, we could graph that function. We could see that it's a linear function. For every one x value, there is only one y value. And we're going to, again, kind of review that today. So I have some vocabulary here, so if you want to follow along in your notes and use a highlighter, I'm going to just highlight important key elements in the first part of this. So when a relation is represented as a set of ordered pairs, we call the domain of that relation the x values, and the range is the set of y values. So first of all, a relation is just a group or set of ordered pairs. So there's a vocabulary word we need to know. Also, we need to understand that domain is a relation where we're just talking about all the x values. And in the range, it's just the set of all the y values. So just some vocab there. You may have heard domain and range before, but I think it's a good review. If you haven't heard it before, that this is even better. So here we can see that a relation where each value in the domain is paired with just one value in the range, it is referred to as a function, which we've really already talked about. We've already talked about for every one input, there can only be one output. This is the same thing, just different wording. So in this example here, they want us to identify the domain and range of the relation. So they're giving us a set of ordered pairs. So they also want us to represent it using a mapping diagram. I don't use mapping diagrams a ton, but you might see them on, let's say, the Kansas assessment or like on a map test, something like that. So it's nice for you to be familiar with. So in this problem, it also says, is the relation a function? So what we can do is first we list the domain. So that would be the set of all the x values. Notice they kind of put those in fancy brackets there. Then we have the range, which is the set of all the y values. Notice if a number repeats itself, we only need to write it once. So anytime, for example, here we have a 3 with the -2, and then we have a 3 with the 1. Anytime it repeats, when we're listing it as a set, we only need to write it once. Okay. Now, this example here is our mapping diagram. So I'm just going to draw an arrow here. The mapping diagram basically kind of lists all the domain and all the range and then kind of matches them up with arrows. Notice that each number in the domain is mapped to only one number in the range. So that means this relation is a function. So I'm going to highlight that as well. Remember, as long as for every one input there is one output, that it will be a function. So this type of mapping diagram works to show that that relation is a function. So let's look here at an example, and we'll do another mapping diagram. So we're going to identify the domain and range, and then we're going to decide if it's a relation. So of course here I'm going to have my domain. So I would list all of my x values in the ordered pairs. I only need to write it once, so if it repeats itself, I only write it one time because there's two that are 4.2, and then we have 5 and 7, okay? Then I'm going to list all of my range values here, and I just put them in order. So 0, then we have 1.5. It's hard for me to read some of this, so sometimes I'm looking at my copy. So that's why I'm looking to the side, because I want to make sure that I'm writing the correct numbers here. Okay, so here's my kind of similar mapping diagram. I had to set it up more like a table, but same idea. And then I'm going to switch colors here, which you can also, and I'm going to match them up with my arrows. So 4.2 has a 0 for a value, but it also matches up with 1.5. So right away, can I answer the question, is this a relation, or is this relation a function? Well, for every one domain, is there only one range? In this case, I have to say no. For every one domain, there's actually two ranges. So that creates that vertical relationship on the graph, which we can't have if it's a function. So I can still continue this. 5 is going to match up with 2.2, and 7 is going to match up with the 4.8. But right here I can see, because there are two ranges for the domain, we would say that this is not a function. That doesn't work. Okay. And just something to be aware of that you can see if you are making a mapping diagram there. Okay. Let's move on. I had to turn the page here. Now, in this example, again, I'm just going to highlight some information. So I'm going back to my highlighter. You can determine whether or not a relation is a function by also looking at the graph. If a vertical line is drawn anywhere on the graph, so if a vertical line is drawn anywhere on the graph and passes through 2 points of that relation, then it cannot be a function. So this is called the vertical line test. So if we look here at this example, it says, is a relation shown below a function? And go ahead and use the vertical line test. Well, if I draw any vertical line anywhere along this graph, is that vertical line going to hit that graph at more than one location? So if we look here, I can see this second line here. It hits the graph at this point, and at this point. So we have a situation. So notice that 2 of the dashed vertical lines pass through just 1 point on the graph. However, the middle one here passes through 3 points. So that would mean it is not a function. You cannot have more than 1 point at a time using that vertical line test. So if you have to graph it, you can see pretty easily, but think about there should be no points that are vertical. For every one input, there can only be one output, okay? So in example 2 here, we're going to identify the function using the vertical line test. So what I would want you to do is graph those points. So go ahead and do that now, and you can pause if you need to. I'm going to just do that real quick. So I'm going to go over 4 and up 2. and then over 1 and up 2, and then 0, 1, -2, 2, and 3, 3. 1, 2, 3. So I've got kind of this weird shape going on. If I want to, I could kind of connect those together like such. Not a great graph, but we see the idea. So would this graph pass the vertical line test? So if I were to draw a vertical line anywhere along this graph, as long as it only, that's not a very good vertical line, is it? Ooh, that's totally awful. Sorry. As long as you're drawing that vertical line, or think of your pencil as your vertical line and just put your pencil or pen straight along the graph, you will see that it never crosses the graph except at one point. So this graph would pass the vertical line test. So we would definitely say yes, it is a function. Now we have 3 more quick examples here. The first one would be evaluating a function. So if we're given a function rule, by the way, I want to point this out. We don't always have to use, F or G or Y, but when you have something like this, that we read that as W of X. We call that function notation, so it's something that you'll be seeing. So W of X means that you can read that many words in so many minutes. So how many words could you read in 6 minutes? So you're basically taking that, plugging it into the function rule or equation. So I would say, sorry, I'm going to have to, W of X is equal to 250 times 6. And sometimes we even see it written this way, where they plug in the 6 there to show that we're talking about 6 minutes, or 6 represents X. So that's using our function notation. So then we could also write our answer as W of 6 equals 1,500 words. Just answering the question. So that's, again, using that function notation style. The next question wants you to find the range if you're given the domain. So remember that the domain represents your X values. So all of these in this set represent X, and they want us to find our range or solve all of them for Y. So I'm going to say then our range would be all the values. I'm going to draw my little fancy bracket there. All the values that when we plug in 1 for X, or plug in 3 for X, or 5 for X, or 7 for X, we can solve then for G of X, which is again function notation, but we could also think of it as Y equals. It's just another way to write it. So we can always take function notation and replace it with Y. If you want to do that, you can. So when we plug each of these in, you guys should end up with -8, and then 0, and then 8 and 16. So that would represent my set of my range values. You could also think of this in like a table format. And I'm going to totally run out of time on my recording. So I'm going to have to make another really short one, and I apologize. This isn't going to work because it's going to cut me off. Okay, so just a second, and we'll do another video for the last part of this.